Welcome everyone to the third video on the Rust GUI world. And today we have two of the most feature-complete Rust terminal user interface frameworks, Ratatui versus Cursive. Introducing Ratatui, a fork of the now discontinued framework TUI-RS that was started by some devoted members of the community who wanted to see the framework reach new heights and succeed. It's a very lightweight library that continues to provide all the tools and widgets you would need to build any application in a simple, intuitive way. The framework itself natively supports terminals on Linux, Windows, and Mac through low-level backends like Crossterm and Termion, but with no support for others like Wasm. Next, we have Cursive, a declarative terminal user interface that handles everything you'd need to easily create an application, including input. The framework is truly a great way to create complex user interfaces, not only in the terminal, but also in the web through an optional Wasm backend. For the creation period of today's episode, I built the same HTOP NeoFetch hybrid in both frameworks. To uncover the story of that, let's first see the backend code and crate that I created for today's episode.
Okay, here we have the backend for both of the applications. It's just in a crate that I'm calling HW Linux. It only works for Linux, as I mentioned before. You can see, I guess, on the side here, that everything is split up into different modules. So memory, host, GPU, all of the different categories, the statistics will be inside of the actual applications. I guess let's actually look at something like memory. To get most of the information, like memory, I actually go inside of the proc files, for a lot of them at least. And basically the proc files contain a lot of information, in fact. So if I say cat proc mem info, as I have there, you can see stuff like total memory, free memory, available memory, and the same statistics for swap. So basically all of your memory information will be accessible there, which I think really cool. And it goes for other information on your computer. Like if I do cat stat, proc stat, you can see all of your information regarding your CPUs. It may be a bit difficult to decipher, but basically the first row just contains the CPU name and then all of the information specifically about the times used by a variety of processes, like your idle time and all of that. And from that you can actually get the amount of usage for each CPU core, which I think is really cool. Or thread, because it's technically showing all of the threads. And in fact there's even more when it comes to proc, like GPU information. If I say cd proc driver feature, let's go inside of Yahtzee. So you can see all of your GPU information inside of here. That's the NVMe, the PCIe bus name. So 000, that's the PCIe bus name there for my specific GPU. And then inside of that you can see information regarding power, registry, and of course the regular information like the model name and all of that type of stuff. That's not how I'm doing my GPU though, because for some other information it's actually better to use other pieces of software installed by default in most Linux distros, like in this case lspci. This is actually how NeoFetch and most NeoFetch-like programs get their GPU information. It may be a different command, I'm pretty sure. Let's exit that. So when it comes to lspci-nnk, this is the result you get, and all of the GPUs will have this like VGA or like an identifier here that can be linked to GPUs, like VGA, 3D display, all of that. And from there you can get all of your information regarding the name of the GPU, the vendor, and the driver even, which is why I specifically use lspci-nnk, because if I were to just use, lspci-mm, I think, you can see the same type of information, but you can't actually see the GPU driver, which is why NNK is one I'm using for this specific application. And then the last unique thing are packages. So for packages, I'm actually going to -user-bin, which is where all of your program files and binaries are going to be stored in Linux including package managers. So if I alice -user-bin, alright. I don't know why it's showing weird things out of me of him, but you can see a variety of different information. If I grep, I don't know, DNF, you can see all of the different DNF files there, and that's how it's able to see that I have DNF installed and know that it can do DNF list installed. And for all of these, when I say like DNF list installed, it's just going to say the name of all of the different applications installed on my system. And then from there, I can just loop through and count. Yeah, loop through and count all of the different names of the applications. And you can see how many have been installed. I'm pretty sure that's actually how it's done in most of these like NeoFetch-like applications. And then the last way we can get information is by looking at environment variables. Like if I were to say echo user, for example, you can see my username, or shell, and you can see that I'm using ZSH, or term that I'm using tmux, right? You can see all of that different information by the different environment variables from the Linux system. So yeah, proc files, different commands, and environment variables is how most of the information is gathered, I guess. There's not much I can really talk about. Yeah, this is the core information. You can see all of the different fields have something associated to it, and using that information, we can see the usage. It has one dependency, this error, which is just for the error handling, obviously, and that's all of the information. I might update it, or might upload it to Creator.io. We'll see how that goes. But it's only for Linux, and there's already a much better create code system for available.
As a disclaimer, I only created these applications to work on Linux, and I kind of wish I did more research, because in the middle of building the Ratatui application, I discovered that there was a cross-platform crate that did what mine did, but better, and with great documentation. So check out sysinfo if you want to see that. But anyways, if you'd like me to take these applications forward in the future, I would try and make them cross-platform and work much better. The application itself, however, will contain 3 pages. The first will display all of your system information, like NeoFetch, showing stuff like CPU, GPU, and disk specs, and also packages and environment info as a whole. For this page, I wasn't worried about making it frequently refresh, because its main purpose is to show a snippet of your system's information. The next page uses sysinfo to get all of the CPU thread information and display their usage to the user, while semi-regularly updating them, kind of like what you'd see in HTOP or in like a system monitor type application. Then finally, in the last page, the HTOP inspiration comes into full view, as I basically copied it stylistically to create a view of all the system's processes to the user, where the user can kill processes, see the user, and a bunch of information regarding each separate process. Finally, both applications were to be styled using the cat puchin mocha theme to display some of their theming capabilities, and for me to check all of that out.
Okay, I have 2 tmux panes open here. Let's build up the different applications. RSinfo cursive, that's the cursive one, and then RSinfo Ratatui. So I've already measured the amount of time it takes for these, but as you just saw, the Ratatui one is so much quicker. That's probably down to the framework crate itself. If that's something you want to look at, I guess Ratatui is quicker, as I think most people would expect it to be. But anyways, using the Ratatui application, you can see that the application is divided into 3 different screens. As I mentioned before, here you can just see all of your system information, like your host information, like what device you have, the vendor, and kernel information, like the exact kernel version and release you have, your user, terms of environment, shell, terminal. That's all the stuff I covered really. You can see also your CPU information down to stuff like temperature and frequency. I wasn't worried about how frequently it updates this screen in particular, because it's just meant to be a snippet. Yeah. Anyways, Something else I should mention is that for disk and GPU, if you have more partitions, let's say, or more GPUs, it will display all of them, or at least will try to display all of them. And yeah, that's also just a bit of iteration, I guess, showing the iterative abilities of both frameworks. And you can see the exact same information inside of the Cursive one, your host, going to environment. Apparently I forgot to name the packages one, so unfortunate, but you can see everything almost the same. On to the next page. So here you can see your core usage from, or at least your thread usage for each of the different ones. This page is meant to be updating semi-regularly at least for you to see up-to-date information. And then in the final page, you can see all of your processes. Yeah, this is very heavily team HTOP inspired, I guess. So yeah, every single process on your system, really cool. And I guess to showcase the abilities, I'm gonna kill the cursive pane, and it ended. So yeah, that's the overline of the applications, and I guess let's see the code. Okay, yeah, here we have the code side by side. Again, the Ratatui one to the left and the cursive one to the right. So here we can just see that everything is split up into different modules, I guess, for core, stats, processes, and main. Those are just the different screens. Bar main, which is just actually starting the application. So let's open that on both panes. So everything here at the beginning, exact same. My jump, everything up to there, it's almost identical. And then we get to the really interesting stuff on how these frameworks work. Let me delete that actually. So for both of them, we need to initialize the terminal, I guess. For here, we're gonna say Ratatui init, and for here, we're gonna say cursive new to just initialize the cursor struct. And here, this will actually provide us with a struct they call default terminal. And it just has the backend as well there. In fact, inside of cursive, we actually specify the backend in a running it, which I guess is something I didn't notice before. And here, we're going to run the application. We're going to get its default state and then run it with that default terminal that was created here. So for the, I guess, structure of my application, I have a struct that contains all of the information, an enum that contains, or that has the 3 different pages, so I can just keep track of that. And the struct does have a page, enum variable value there. And when they do run the application or the struct with the default terminal, we can see that we are first checking to see whether the application needs to be exited out of, like if I hit Q or escape or whatever value I have for that. And then it's going to draw it. Here, this is the draw. And I think I should just go into the, I guess, how Ratatui and Cursive both deal with, I guess, rendering the UI in slightly different ways. Let's open up stats on both sides. This will give us a more clearer interpretation on how it works. So inside of something like memory here, we're going to see that for dialogues and blocks, they kind of work in slightly different ways. So inside of Ratatui, we're going to have the children of the block, and then we're going to specify what block the children have. Whereas inside of Cursive, it's kind of the block itself, and I'm specifying its children, what's going to be contained inside of it. As you can see here, table new, and then I'm specifying the block here, dialogue around, and then I'm putting my table there. It's slightly different methods of doing it, I guess. And then we can actually go into the width. So here we're specifying the space given to both sides of the table. If I go down here to Cursive, funny enough, about tables inside of Cursive, it's not actually built into the framework, which is a bit unfortunate and weird. It's kind of the first time there hasn't been a table built into the framework when it comes to the Rust GUI wars. But there is a community maintained crate that does handle it and handles it pretty well. So here we can specify the width percentage. They're slightly different between the two frameworks, which is just a me thing, not because of the frameworks. But yeah, 25, 75, same thing here. It would be 25-1. The fill is just going to say the rest of it is dedicated towards that. You could say percentage 20 and then percentage 80 if you wanted to. But yeah, that's how I'm handling the width. And yeah, that's kind of how it goes. For tables as well, I should go here. They kind of handle in the same way, or at least I try to make it be handled in a similar way, where I have this rows vector and I'm pushing rows into the row vector, and then added to the table. Same thing here. We have the rows vector. I'm pushing rows. And to try and get the same effect, because this is how Ratatouille handles tables by default, I was inside of Cursive, I kind of had to force it. I just created implied new inside of the row, where I can just input a vector of strings and it will create a new row based off of that. Otherwise you'd have to say like row, and then you'd have to do like the long way around when it comes to structs inside of Rust. But to make sure that I could just, Control C, Control V, between when I was creating the Cursive application, I just tried to make it handle in a very similar way. And I think that's the main things, except for maybe styling. So when it comes to styling, of course, Cursive has their theme.toml file. This is just an alteration on what they'll give you by default to make it try and match the Ratatouille, the cat butchering theme. Whereas inside of Ratatouille, if I go to the bottom here, you have to specify each different style for all of the different parts, let's say. So here, I'm creating a new bordered block, and then I am aligning the title. And then for the title style, I'm giving it a foreground value. That's just saying the text itself should be color red. And then for the border type, border around it, all of that. Whereas inside of Cursive, it's just a common theme file that will apply its theme all throughout the entire application, which I think is really cool. But yeah, those are the code behind both applications. Really cool stuff.
Now, let's build a counter app together using each framework.
Okay, here we have the Ratatui Counter application. Let's start from the beginning. First, I'm initializing the default terminal using Ratatui init, and then I am running the counter app. And inside of the counter abstract, I just keeping track of the count and of course whether we need to exit or quit. Very similar stuff to how it's handled inside of the application I showed before. And then while we haven't quit, I'm just drawing, and inside of draw, I'm just frame.render widget. It's just a paragraph that's centered and emboldened with a block around it that's bordered, that has the title Counter App, that is blue. And if you actually look at the application here, cargo run, we have the blue title, the centered counter text that is emboldened. And of course, we need to go on to events. So after we've drawn this GUI, we then handle events. So inside of the events function, I am polling to see whether, I'm polling every 100 milliseconds to see whether the user has done an input event. If they have done one, we can then read that event. This is a non-blocking call. This is blocking. So this one will pause the thread and make sure that you can't actually progress, which isn't really that important when it comes to this exact application. But let's say in the previous application I did, I couldn't have a blocking call. So I needed to first poll to see whether there was an event, and then I needed to then read, which then could then, block. So here I'm matching it to see whether it's a key press. If it is a key press, I'm trying to see which key code it actually is. And then plus or equals, that's just because most keyboards combine them into one key, and you may need to hit shift to get plus, and vice versa if it's equals or whatever, to increment the count. So here you can just hit that key and you increment it no matter what value it's actually going to give us. And then of course we're just saying after count plus equals 1, that's just incrementing it. Same with minus equals 1, that's just subtracting it by 1. Then if you're at 0, we're just going to reset the count, and then space will add a random number between 0 and 100. Let's see that functionality working. Yeah, I'm adding it, subtracting to it. Then I'm going to reset it to 0, and then I can add a random value between 0 and 100. And then reset it again if I want it. So yeah, that's the Ratatui application. It was really easy to code, honestly. Not that complex. I really liked coding inside Ratatui. On to trying to build Cursive. Okay, after totally not taking 30 minutes to build a counter application, we have the complete Cursive Counter application. Finally done. Yeah, didn't take me that long. Anyways, as mentioned before, we are first creating the cursive struct here that I'm then setting the theme to. Here we have it with that current theme. If I were to get rid of this cursive.setTheme, we are going to end up with this. It's a more retro theme. Some people may like it more, some may not. I just set it to the terminal default. Onto these two closures. Actually, let's go here. So to of course draw the actual UI, I'm first having a text view with the count, which is going to be 0 at the beginning, and then I'm putting a dialog around it with the title Counter App, and I'm full screening it. Let's just show the functionality if I get rid of full screen. So here you can see it's covering the entire screen. If I recompile it, you see that's only going to be big enough specifically for its content. So that's why I full screened it before, to make it I guess the same as the Ratatouille application. Anyways, for the text view inside of the dialog, I'm actually giving it a name, which is count. This allows me to access it anywhere within the document or within the code base itself and change its value, which is really important when it comes to a counter application. Here we have 4 different functions. Obviously, as mentioned before, we have add, subtract, reset, and randomize, increase, I guess. So for add, we have this closure here. That's just to make sure that plus and equals do the code the exact same thing, not having to do this twice. Just code reusability stuff. But in these closures, I'm actually calling on the name. This allows me to access this text view, and from there I can actually get the content from this text view, that's 0. Then I'm going to pass it into a signed 16-bit integer that I'm wrapping, and then adding 1 to. Same goes if I want to subtract or add a random value between 0 and 100. Whereas when I'm resetting, I'm not actually getting the content at all, I'm just setting it to 0. And that's about it. At the end, of course, we run the Cursive application. I could even run it with a different backend like cross-term here. The exact same application will pop out, and of course it does work. Here I'm adding, then I'm subtracting, then I'm adding with a random value between 0 and 100, and then I'm resetting. So everything does work as you'd expect, and that is the Cursive application.
Before we start ranking, I just want to say that although both frameworks are TYs, they serve very different use cases, as Ratatouille is more suited for applications like dashboards, or for example, the application I built in today's video. Just times when you need frequently updating UI that requires very little user involvement. Whereas, if I were to build a settings application, for example, I would choose Cursive every single time. It was made to build more complex applications with many menus and pages and nested views and all that. Even when it comes to mouse input, for example, Cursive has really good support and enables it by default with no weird workarounds and whatnot. Anyways, TLDR, both frameworks are made for very different situations, and the results should be taken through a Ratatouille covered lens. Finally, it's ranking time, as we get to put each framework on the Rust GUI Wars leaderboard, which you can view in the description below. And if you want an overview for each category, check out the inaugural episode for the Rust GUI Wars. Anyways, let's start with Ratatouille. For OS support, Ratatouille manages to get a decent mark here, 3 out of 5, because of its support for terminals on Mac, Linux and Windows, so 3 for 3 out of 5. For TUIs, it's a bit difficult to judge tooling. Usually, I would look for CLI tools to help developers with running the application, or I might look for language servers for the framework's custom language, like for Slint. At least in Rust, no TUIs have features like those, but in the case of Ratatui, they do provide templates and instructions to use those templates with cargo generate, which gets it a point above 1. Ratatui's documentation is great. Obviously, besides the customary docs.rs page, they also have a website with built-in examples and explanations. The website also covers topics like async and all the stuff beginners may need for their application, like, the widgets. All of them are covered on the website, which is really great, and more frameworks need to do that, so that you can see and have an example of what each widget looks like and what each widget does. They also have many greater examples on their GitHub repo that go further in depth into building larger applications. It's a truly great framework for those wanting to dip their toes into creating great UI easily for their first time in Rust. So, a 5 out of 5 for community support and documentation. I found working with Ratatui so intuitive. The immediate mode nature of the framework is my preferred method. Plus, although I personally decided against it for today's episode, it has very clear examples of using the framework in different architectures, like the ARM architecture. So, an easy 4 out of 5 for the Ratatui team here. For theming, it's a bit difficult to judge because of the massive difference between the style of applications that are created between both frameworks, as you'd have seen throughout the entire video. But what I will say is that in Ratatui, you can match your application to whatever theme you want. However, there are no pre-built themes and there's no built-in system for loading themes from files easily. So to have a consistent theme, you need to specify the style for each UI element, which is good because it does encourage code reusability, but can be a bit annoying at times. So unfortunately, I'm probably gonna have to give Ratatui a 2 out of 5 because of just Cursive being better, and of course GUI frameworks being better in general and having more options. I don't necessarily blame them for 2 out of 5. It's kind of very difficult, and I'm kind of between a rock and a hard place for making the scores kind of interoperable. Anyways, onto the Cursive breakdown. For operating system support, Cursive went above and beyond, allowing people to use the WASM backend for web support, which is really impressive for a terminal user interface. Plus, it also supports Mac, Linux and Windows, like Ratatui. So, 4 out of 5. As mentioned before, I was a bit torn on how to judge the tooling of Rust TUIs. However, what I can say is that Cursive doesn't really provide the user with as much tooling as a framework that is as 10th as developed as it and as old as it is. I really recommend that the team look for potentially having official templates for beginners to easily start, and for people in general to create new projects depending on what features they want. So unfortunately, it's getting the lowest mark here, or second lowest. I don't think I've decided on that one yet. 1 out of 5 for tooling. Although Cursive doesn't have their own documentation outside of docs.rs, they do provide quick start tutorials on their repos for beginners, which is always nice. Plus, they do have a wiki on their GitHub filled with information. I'd still like for the team to have a website that can ease potential developers into the framework and explain its purpose, features and ideology. For developer experience, Cursive is an interesting case, and I think I'm slightly biased because of the mediocre documentation. I struggled to implement certain features at first, but once I got a handle on it, I could iterate at a decent pace. Additionally, the .toml theme files are a centralized place for developers to access and change theming, which also helps it here, as changes can be made very quickly with no hassle. It's really an intuitive way of handling it. I'm surprised that more frameworks don't do this because of how good Rust.toml supported. Kind of unfortunate, but yeah, really nice thinking Cursive team. I love it. The final score I landed on was a 3 out of 5 for developer experience. For theming, Cursive is really impressive, especially because of its .toml theme files that can be loaded in at runtime and changed easily with built-in functionality from the framework. Additionally, because it uses theme palettes, that ensures that the application stays consistent and is simple and easy, of course, to theme. So an easy 4 out of 5, one of the best marks I've given here. Overall, Ratatui takes the victory today with 17 to Cursive's 15. They do round out the bottom two, but the context should be taken in that these are both GUIs and they are trying to compete with GUIs and web frameworks, so it's a bit biased against them. And honestly, those are really good scores for what they are, and I think they have a lot of interesting features that could be brought into other types of frameworks. I really want to see them improve, but I'm truly impressed. And of course, the Ratatui team managed to provide a top-notch experience that probably makes Ratatui one of the best GUIs, regardless of language. It's easy to use, intuitive, and probably going to be my default TUI from now on. Both frameworks put up an incredible fight, and I'm sure by the next time I review them, they'll be so much better and will have fixed their respective issues. However, in the next video, we're going to see a clash between two of the best GUI frameworks, Flow versus Vizia.